Well, hello everyone. I know it has been long since the last video I released, probably a week, and I was busy into some things. But I'm sure you guys don't want to listen to my struggle story, not at least before I'm successful. So let's just begin the video. Today, what we'll be doing is we'll be discussing a maths question. It's a really good question. You could say it's not like RMO level question, but in approximately in that range. Like if you're preparing for RMO or any good Olympiad like that, then this question will be useful for you. So it's a tiles and all fitting question. So let's begin with. Right. So let's read the question. This is what the question says. That let's say you are given, over here, that is 8 cross 8 board, or it could be any, maybe 6 cross 8 or anything like that. So let's say the one that is marked in red, that is the first one and the last one, right? Let's say these two I'm removing out. Okay, on my board, the first and last square I'm removing it out. Okay, now what board we are left with? We are left with this much board, right? This is what we are having. Now the question says that can 2 cross 1 tiles, right? So we have this kind of a tile in which we have 2 cross 1. The question asks, can I use 2 cross 1 tiles to fit my entire board? Like let's say if I keep putting it everywhere, then will I be able to fit it, or will there be a situation wherein I just won't be able to fit the complete board? Like it will be something like this, like if the board is like this, and let's say there's one square outside, so like I used all of my tiles and one of the board, like I can't really cover it, it's some orientation like that in which I can't cover it. So is it that, or is it that using my 2 cross 1 tiles I can fit it completely? Now obviously it's not an easy question, that's why the question is made like this. So I guess you can understand whatever will be your answer. Like let's say if you are saying that you can fit it, right, you can use 2 cross 1 tiles and just put like this, like this, like this, and you can fit the entire board. Then you need to just show me one arrangement in which wherever you have put the tiles, it has completely taken the board, like each and every square is occupied. It's not like any one of the square is remaining, right? So, and if not, if you're saying that no, we can't use 2 cross 1 tiles to like fit the entire board, like always there will be a situation where two tiles, or one of the tiles, they won't be able to fit, like they won't be taking the complete board. If that is the case, then you need to prove that. Whichever is your answer, you need to prove that. So let's go with the solution now. I'll be explaining that. Now the answer of this is really interesting. Some of you might have had the intuition of the answer, some of you might not have, but the way how you write your answer, that is you present it, and that is how you can actually appreciate the beauty of mathematics. Like the proofs comes within such amazing ways. So anyways, let's look at the solution. The answer is that obviously it's not expected, so the answer is that we can't use these 2 cross 1 tiles to actually fit the entire board when I remove these two blacks that you can see in the green. Why is that happening? I mean, earlier it was like let's take an example over here, 4 cross 4. So earlier there were only 16 squares, right? So if I take out 2, I have 14, right? So if I use 2 cross 1 tiles, then okay, if I use 7 2 cross 1 tiles, it should be able to fit all of my 14, right? That's what you think. But that's actually not a case. In fact, you can try each and every arrangement over here. You can try doing anything. You can try doing this, anything I have shown over here. You can see these both are remaining. You can try any other case. It won't ever happen. Now, why is that happening? You see, I purposefully said that I'm removing this tile and this tile. Okay. Now, where does the answer lie? Now, if you can see over here, I have marked from red all the alternate as black, and the other ones you can assume them as white, how it is on the chessboard, right? So now we just have to focus our attention on how do we prove that it is not possible. We know the answer now. Okay, like once you try 5-6 times this kind of arrangement, right? You do trial and error, and you understand that okay, it is not working out really. So you have that intuition in your mind that okay, now I just have to prove that why it is not going to work. Once you know the answer, you can try to approach that. You can try different approaches by which I can prove this, right? This is RMO. You are given 15 minutes for one question. But why is it so hard? I mean, when I tell you the solution, it's going to look easy to you. But once you start solving it, you have to do trial and error. You have to understand like what will be the answer. Then you have to try different approaches of how can I approach to this answer. You have to prove it. This is RMO. You have been given 15 minutes. You have to utilize this 15 minutes and come to the answer. You do trial and error. You do the question that I gave you 8 cross 8 tiles, right? but now when I'm explaining you, I'm using this 4x4 tiles. When you are solving it, you could take a 2x2 tiles. Now see, this is really interesting. Yeah, let's just let me right, so let me do this. Let me take a 2x2 tile over here, right? This is when you are experimenting, you know, black, like, okay, like when you remove these two, you can see by using 2x1 tile you can't fit this weird looking kind of shape, right? So you know, you do all these experiments and you understand that okay, fine, whenever you know I'm doing this, it is just not possible. So now I just have to think of a proof, mathematical proof by which I can say that okay, you know, why it is not working. So that is where we really need to do our focus on. Now I'll be explaining the actual answer. So I hope you understand this trial and error thing. You have to do trial and error and you have to understand, okay, this is not working, I just have to prove it now. Then you start using your mathematics into this. Okay, so right, my first statement, that is that every 2x1 tile, right, that you can see over here, every 2x1 tile takes one black and one white. If I assume it as a chessboard wherein everything that is marked in red is black and the other ones are white. So over here every 2x1 tiles takes one black and one white square. Okay, understood, cool. Second statement, number of blacks before I remove it, they were 8, right? And number of whites before, they were also 8, right? Now once I remove the first and the last, right, after that my number of blacks is only 6, but my number of whites is still 8. So how is it possible? How is it possible that using 2x1 tiles I can cover each and every one, right? You do whatever, let's say whenever you are using your 2x1 tiles, right, for these 6 blacks you'll get a white, but then you'll have 2 whites remaining, and they will be always in such a position that you can't cover them, like one will be over here and one hole will be over here. So that is why it is not possible. You have to understand this. And you see, this is the beauty of mathematics. If I would have told you, let me use green color. So if I would have told you I removed this one, this one, this one and this one. Let's say I have not given you black, okay, I'm just giving you a simple square board. Okay, let me do that also. Let me quickly show you what I'm trying to explain over here. So let's say, you know, if I just gave you the board like this, you know, 2 3, and let's say what if I told you that okay, I'm removing this tile, I'm removing this tile, I'm removing this tile, and I'm removing this tile. Now tell me, using 2x1 tiles, can you cover it or not, right? Or let's say I told you, tell me, using 3x1 tiles, can you cover it or not? Now you see, now your brain will start working. Okay, in 3x1 tile, or in, let's say I gave you a 4x1 tile and I gave you a, you know, a weird thing like maybe 20x20 square board, and I told you that okay, I'm removing 4,3, 3,4, something like that. So how will you approach that problem? Let's say you were given directly that problem, how would you have solved that? This is how you would have taken a small problem, that is okay, let me first take a 4x4 grid and I'm using 2x1 tiles. So then how does it work? Once you understand the approach of that, then only you can think of how to solve a big problem. Now this is what mathematicians do. They, whenever they are given a big problem, or even when they are given a small problem, they try to extend it to the maximum level that they can. Now once you understand this, that okay, so right, I'm removing this and this, right? So over here also black, 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 definitely not possible. Number of blacks would be less than the number of whites, so it is not possible. Now you can come up with so many amazing questions. This is the beauty of mathematics. Okay, I'll tell you that fine, I'll take a, you know, 20x20 board, and I'll remove, what all will I remove? Maybe I'll remove 1,2, that is the one over here, and then maybe, you know, I'll remove some other 3,4, I'll remove some weird things, and then I'll tell you that okay, tell me, using 4x1 tiles, can I do it or not? Now you'll think, okay, in 4x1 I have 2 blacks, 2 whites, then whichever we have removed, you will count the number of whites and number of blacks left. You know, let's say I just gave you 6 random squares and I told you to remove that. How will you approach this? That just sounds so scary. But once you start thinking in a mathematical way, you take a smaller problem, you solve that, then you apply it on a bigger problem. That is how you can solve any mathematical problem. The video is getting very long. Guys, bye bye, see you again. Please like and subscribe. These videos take like huge amount of